Hello everyone, welcome back to our Python programming course. I hope you are doing great. In previous lecture, we learned about function, lambda function, and decorator, scope, recursion, generator, and range, array, iterator, and module. So, now it's time to start one of the most important topic in Python. The topic name is OOPS, also known as object oriented programming. This is one of the most frequently asked topic in Python interviews, placement exam, software development, web development, data scientist, and Django projects. If you understand OOPS properly, you are building a real life application like student management system, banking system, hospital management, library, shopping website, and so on. In today's lecture is very important. By the end of this lecture, you will understand what is OOPS, why OOPS is used, and real life example why companies use OOPS. The first question is, what is OOPS? OOPS is a programming paradigm based on the concept of object, which can contain data in form of field and code in the form of producer. Before understanding the definition, let's understand it with a real life example. Suppose you buy a new car. The car has engine, wheels, brake, accelerator, and door. These are the data properties. Now think about what the car can do. Start, stop, turn, accelerate, and brake. These are the actions or method. A real world object has property and behavior. Python OOPS follow the same ideas. Now what is the definition of OOPS? OOPS is a programming paradigm that organize programming or program using object. An object contain data and method. In simple words, OOPS is a way of writing program using objects. Now, breaking the word. Object oriented programming, let's divide it. The object, anything that exists in the real world. For example, student, car, mobile, laptop, teacher, dog, cow. These are objects. Now, oriented means focused on object, and programming, writing instruction for a computer. Object oriented programming means writing program using object. Let's take one real example. Suppose there is a student property, name, roll number, age, and course, and behavior, study, attend class, and write exam, submit assignment. Student equal to object. For one more example, now a mobile phone. Properties like brand, model, color, RAM, storage, and behavior, call, message, camera, internet, music. Mobile is the object. Now, third example, bank account. Their property is account number, name, balance, and behavior is deposit, withdraw, and check balance. Again, everything is an object. Why do we need OOPS? Now imagine you are building a banking application without OOPS. Everything is written in one file. Thousands of lines of code very difficult to understand, very difficult to debug, and very difficult to update. So instead, oops divide the project into small objects. For example, customer object, then account object, then transaction object, then loan, then ATM object. So everything become organization. Now what is the advantage of oops? So reusability. First is reusability. So write code once, use it many times. Second is easy maintenance. Finding and fixing bugs become easier. Now better security. So data can be protected using encapsulation, and easy to understand. Large product become smaller and more organized. And fifth one is real world modeling. So we can represent real world object directly in codes. So where is oops used? So oops is almost everywhere, like Instagram, Facebook, Amazon, Flipkart, banking software, and hospital management, school management, games, and desktop application. So almost every large software project use oops. Now important terms, like student remember these four words, like class, blueprint, object. So object, real thing create from the blueprint, and attribute is data. For example, name as salary. So the method is action. One more example, study, drive, and withdraw. So don't worry, we'll learn each this in detail. So now, is a car an object? So the answer is yes. Is a student an object? So answer is yes. Can any object have both data and function? So the answer is yes. So now let's understand oops was introduced. So before oops, programmers used procedural programming. So today we will compare procedural programming and object oriented programming. So what is procedural programming? So first let's understand the meaning of the word procedure. So a procedure means a sequence of steps to complete a task. So in procedural programming, the programming is divided into function or procedure. So the focus is mainly one function, not on objects. So procedure is is a programming approach in which a program is organized into functions. So that's execute once after another. For example, uh, procedural language like C and Pascal. So imagine a banking program like if I write def, then deposit, then print money deposit, then def withdraw, then I print this. Then desktop or deposit, then withdraw, so if I run this, the output will show money deposit, then money withdraw. So everything is written as a separate function. So now problem with procedural programming. Now imagine a project with 5,000 or 50,000 lines of code. Now problem began to appear. First problem is code repetition. The same code may be written again and again. Second one is difficult to maintain. So if one function changes, many other function may also need changes. Now less security. Talk about third problem, less security. So program data can often be accessed or modified easily if not carefully managed. Now fourth problem, difficult for large project. So large software becomes difficult to manage. For example, Instagram, WhatsApp and Facebook. So these applications are too large. So now what is oriented programming? So object oriented programming solve this problem. Instead of focusing only on one function, it organizes programs using object. Each object contain data and functions. So data in attribute and function method. So everything related to an object stay together. For let's understand with a real life example. Suppose we create a student object. Instead of returning many separated function, we keep everything together, like student, then name, then age, roll number, study, attendance, class, and give exam. So everything belong to one object. This makes a program organized. So now procedural programming, difference between OOPS and procedural programming. So in procedural programming, focus on function and data and function are separated, less secure and difficult for large project, and less reusable and hard to maintain. And in OOPS, oops focus on object and data and method stay stronger, better data protection, and easy for large project, highly usable, reusable, and easy to maintain. So now one more example of consumption comparison. So building a school procedural programming, imagine all teachers, student, and classrooms and record are kept in a huge room. Finding anything become difficult. So oops, everything is organized: one classroom for each class, one office for account, and one library and one laboratory. So everything has its own place. So exactly oops. So why companies prefer oops? So almost every software companies use oop oops because it's offer better organization and code reuse, easy teamwork, easier maintenance, and scalability for large application. uh, Companies using oops include Google, Microsoft, Amazon, Meta, and Netflix. Now advantages of oops. So code usability, uh, write once, use many times. For example, create one student class, create 1,000 student object from it. And second one is better security. So sensitive data can be proceed using encapsulation. We'll study this later. Now easy maintenance. If a bug is found, fix it in one's place. The improvement benefit all related object. Now modularity. So a large project is divided into smaller classes, so this makes the development easier. Now easy teamwork. So different developer can work on different class. For example, developer 1 student class, developer 2 bank class, 3 python payment class. Now sixth is easy testing. So each class can be tested separately. Finding bugs become easier. Let's take one more example. Like think about a hospital management system. Class could be doctor, patient, nurse, then medicine, billing, reception. So each class perform its own work. So together they build the complete application. So now uh, now you understand why oops was introduced and how it difficult from procedural programming. So now it's time to learn the most important concept in oops. That concept is class. So without understanding class, you cannot understand oops. So we learn now what is class and why do we need class. Real life example: class syntax and creating first class. and multiple example for practice programs. So now the question is, what is class? So a class is a blueprint or template of creating objects. Means before learning the definition, let's understand a real life example. Imagine you want to build 100 houses. Will you means will while the engineer build every house without planning? So the answer is no. First, the engineer prepare a blueprint or design. Then many houses are built using the same blueprint in Python. This blueprint is called a class. So the definition is like this: a class is a blueprint or template used to create object. It defines the properties or attribute and behavior method that object create from it will have. So a simple definition like class is blueprint of an object. So let's take one real life example. Like blueprint is a house, and blueprint equal to class, and horse equal to object. So one blueprint can create 100 houses. Similarly, one class can create 100 objects. So now example second. Suppose a company manufacture car. Before making cars, they first create car design, and that design is called class. So every car later made later is an object. For example, a student. Imagine IIT admission. Every student has name, age, roll number, course, then section. So this common details define the structure of a student. That structure is the class, and each individual student is an object of that class. So why do we need of class? So imagine we have 100 students. Without class we create like this. Name equal to Rahul, then age. Then name 2. then h2 equal to 19. So again and again and again 100 times is very difficult. Instead, create one class, create many objects, so it easy. So now the syntax of this is very simple: class, then class name, then body of class, then pass statement. So the class keyword used to create a class and a student. So class name always using meaningful names, usually first letter capital. For example, student, car, then bank, employee, mobile. So past temporary keyword means nothing inside the class will added code later. So hello everyone, welcome back to our Python programming course. I hope you are doing great. So in previous lecture we learned the difference between procedural programming and object oriented programming, and we also understand why companies like Google, Microsoft, Amazon and Netflix use object oriented programming to build large software. Now comes the most important concept of OOPS. So today we are going to learn class. If you understand class properly, then learning object, constructor, inheritance, polymorphism and all advanced OOPS topics will become much easier. So in today's lecture we learn about class. So before I explain class, I want to ask you a simple question. Suppose you want to build a house. Will you directly start building the house? So the answer is no. So first an engineer prepare an engineer prepare a blueprint. Now only after the blueprint is ready, many houses are built. Now think carefully. Can one blueprint create only one house? So the answer is no. One blueprint can create 10 house and 100 house, even 1000 house also. So remember this example. We'll use it throughout today's lecture. So now what is class? So a class is a blueprint or template used to create objects. So blueprint and object, these are the most important keywords. So a blueprint is not a actual house, it's only a design. Similarly, a class is not actual object. A class is only tell Python what an object should look like. So the actual object is create later. Remember this point. Many beginner confuse class with object. They are different. So let's understand using a student. Suppose your college has 1,000 students. Do all students have name, age, roll number, course section? So this common details define the structure of a student. So this structure is called student class. Now Rahul is an object and Aman is another object. So all these students are created from the same student class. So let's take one another example. Suppose Samsung launch S25. Before manufacturing millions of phones, the company first create one design. That design is the class. Every phone manufactured after that is a object. So now imagine we don't have classes. Suppose we have 100 students, and without class we'll create 1,000 variables or 100 variables like this. Student, student 1, then name equal to, then student name, and second student age, age equal to 20, then student course is BTech, then student second name, then age, then course. So again and again, hundred of times. Can you imagine how much code we could write? So it's very difficult and very confusing. Instead we create one class, then create hundreds object. So now first type this keyword class. So this keyword tells Python that we are creating a class. Now after the keyword, write the class name like student, student. Always use meaningful name. Notice the first letter is capital. This Python naming convention. So it is not compulsory, but professional programmers always follows it. So now after the class name, type as colon, and Python gives indentation. Now type pass. So this pass keyword means there is nothing inside this class, yet it's simply a placeholder. Now let's create another class, then car. So run again. Still nothing, because only the class exists, not object. So let's create multiple class. Like class student, then pass, then class student, or class teacher, then pass, class library, then pass, then class course says, then pass. So Python allow you to create many class inside one file. So imagine a school student class and teacher class, library class and account class. So everything is separated, everything is organized. So this is exactly how real software is built. Now let's learn the naming rules. So we learn about class, we understand that a class is a blueprint, but now one question should come into your mind. If class is only a blueprint, then where is the real life things? So where is the actual student and actual cars and actual mobile phone? So in today's so this objects this is one of the most important topic in object oriented programming. So suppose an engineer prepare a blueprint of a house. Can you live inside the blueprint? So the answer is no. Blueprint only tells how the house should look. The actual house is built later. Similarly, class is only a blueprint. The actual things created from that blueprint is called an object. So remember this sentence: class is a blueprint and object is the real things. Uh, Suppose a student is a class and Rahul is a object and Aman is another object. So they all are in same class. Uh, Different objects. So every student has different information, different names, different roll number, different age, but all of them belong to the student class. Let's take one another example, like car class. Objects Creta, Swift, and Verna, different objects, same concept. So first we create the student class like this: class student, then pass. Now outside the class create an object like s1 equal to student. So let's understand this line: s1 equal to student. So this s1 is a variable stored the object, and this student create an object, a new object of the student class. The equal sign assign the object to a variable s1. So now save the file, run it. So again nothing appears. So student object has created. We simply don't ask Python to display it. So now type print s1. So if I run this, the output will show main student object at this. So we understood that a class is a blueprint and object is a real entity create from that blueprint. So we also create multiple object of the same class, but if you remember our previous program, our object were completely empty. For example, we create a student object, but that student had no name, no age and no roll number. So now the question is, how do we give data to an object? So the answer is constructor. So now the question is, what is constructor? So before we understand the definition, let's understand a real life example. Suppose you buy a new mobile phone. The moment you switch it on for the first time, the phone automatically performs some initial setup. You don't manually tell it to create memories. So load the operating system or initialize settings. Everything happens automatically. Similarly, when we create an object, so Python automatically call a special function. That special function is called constructor. So a constructor is a special method that automatically execute whenever an object of a class is created. So it manually used to initialize the object data. So why do we need a constructor? Suppose we need a student object. Every student should have name, age, roll number and course. So without a constructor, we we would have to assign these values separately. After creating every object, imagine creating thousands of student objects. It would take a lot of extra code, and constructor solve this problem by automatically initializing object data. So constructor uh, in Python the constructor is written using a special method is called this init. So this method is automatically called when an object is created. So remember this, uh, has double underscore before and after the word in it. So many beginner forget this underscore. So let's understand this code. This keyword class create a class. Uh, the method init is a constructor. Whenever an object is created, this method run automatically. So if I run this, the output will show constructor called. So notice sometimes we never call this init. still Python execute it automatically. So why? Because the constructor is automatically called whenever an object is created. So now creating multiple object, now modified this program, like if I write s2 then s3. So if I run this, the output will show 3 times constructor called. So observe carefully, how many times did we write, we create? So the 3. Now how many times did the constructor execute? So 3 times. This proves that every time a new object is created, the constructor execute automatically. Imagine a school. Whenever a student take admission, the school automatically create a new record. Similarly, whenever an object is create, a new object is create, Python automatically initialize it through the constructor. So now let's try something. For example, so if I run this program, the output will show nothing, because we only create the class, we never create an object. So remember this important point: a constructor execute only when a object is created. So many beginner thinks they have to call the constructor manually. For example, like if I write student dot init, so this is not the normal way to use a constructor. This is the correct way to use a constructor. Student this. So Python automatically call the constructor. Now look at these two methods. For example, like if I write class demo, then def init, or def hello self, then print this hello, then def init self, print constructor. So the difference is simple. A normal method must be called manually, like this. Object this so the constructor run automatically when the object is created. So now understand the advantages of constructor. So constructor automatically initialize objects and reduce repetitive code, makes program clear, and every object is start with a proper value. It's used in real world application. So now we understand that a constructor is a special method that automatically execute whenever an object is created. So we also learn how a default constructor work. But if you remember our previous program, the constructor only print a message. Our student object still had no name and no age. So now the question is, can we give values to an object while creating it? So the answer is yes. And for that, Python provides sometimes something is called parameter constructor. So this one is most commonly used concept in Python. Almost every real world project use this. So now what is parameterized constructor? So before we understand the definition, let's understand a real life example. Suppose you buy a new mobile phone. When you first switch it on, the phone asks you a language, country, Wi-Fi, then email account, Gmail account, or so these values are give at the beginning. Similarly, when we create an object, we can provide the value immediately. So this is done using a parameterized constructor. So a parameterized constructor is a constructor that accept one or more argument to initialize the object data during object create. So why do we need this? So imagine a college. So there are 500 students. Every student has a name, age, and classroom, course, roll number, like this. So if we don't use this, we will have to assign these values one by one after creating every object. That's mean a lot of extra work. Instead, we pass all the values directly while creating the object. So this makes our code shorter, cleaner, and easier to maintain. So uh, parameterized constructor has a simple syntax like this: class, then student, then def, init, self, name, age, self dot name equal to name, then self dot age equal to age. So let's understand this step by step. So the constructor now accept two values: first the name, then second one the age. So whenever an object is created, these values are automatically stored inside the object. So now we write our first program of this. Suppose um, I write class students, then def init self name age self name equal to name, then self age equal to age. Now S1 equal to student Rahul, then rating, so print S1 name and print S2 name or age so S1 age. If I run this, the output will show the name and the age. So our object now stored real information. Now understand this the program. Uh, let's understand what happened. So first Python create the student object, then Python automatically called the constructor. So this constructor received this name and age, then the value will be stored inside the object. So finally we print them. Simple. Let's take one another example. Let's create another student. For example, student S2 equal to student name Aman, comma 20, print S2 name. So if I run this, the output will show the both two names. So notice something, both objects belong to the same class but their data is different. Now let's take one real life example. Imagine two students. Student 1 has name Rahul and age 18 and course CAC, and student 2 has name Aman, age 19 and course EC. So both are students but their information is different. So parameterized constructor allows every object to store some different data. Now adding more parameters, let's store more information in this. For example, if I add course, so self load course equal to course then CSC print s1 dot course. So if I run this, the output will show Aman, then if age, so the output will show Aman, then 18, then CSE. Now our object stored three pieces of information. Now let an example of a car. So like if I create a class name class, then car def init self brand and color. So self dot brand equal to brand and self dot color equal to color, and c1 equal to car, for example BMW, and color is black. If I print this, so c1 dot print, and I want to create one more thing, color. So if I run this, the output will show BMW, then black. Now let's take another example of employees. For example, if I remove this and create a class of employees, then def init self comma name salary, so self dot name equal to name, then self dot salary equal to salary, even equal to employee, and Raj $50,000. If I print their name and salary, so print even dot name and A2 dot salary or even dot salary. So if I run this, the output will show Raj and 50,000. Now, uh, what is this self? Now you may and have noticed something. Every constructor start with this self. So why and what is self? So we learn self keyword. Just remember that the first parameter of every instance method, including the constructor, is conversationally named self. Uh, Before understanding this self, uh, so let's understand a real life example. Suppose there are three students in a classroom: Aman, Priya, and Raj. So now suppose I say stand up. Will everyone stand? Maybe, but if I say Priya stand up, so now only Priya will stand. Why? So because I referred to one specific student. Similarly, Python also needs to know which object is currently working. So that's work is done by the self. Uh, so what is this self keyword? So self represent the instant object itself. It is the first parameter of every instant method. We use self to access variable and method of class. So why do we need this self? Let's understand. Suppose we create three student objects like student Aman, twenty, and student. So now how will Python know which student name should be stored? So Python need a way to identify the current object. So that identifier is self. So let's understand using this code. I create a class and student and write def init self name, then self dot name equal to name, and s1 equal to student. So if I print this s1 dot name, so the output will show Priya. So let's understand line by line. So first Python create s1, then Python automatically send this s1 as the first argument. That the first argument is received inside this self. So internally Python does something like this: student dot init s1 dot. So now we wrote student Priya. So but internally Python convert it into student init like this s1 Priya. So that means self actually become s1. Suppose s1 student is Priya, so memory look like this: s1 then student object name equal to Priya. Now self point to that same object, like self then student object then name Priya. So self and s1 refer to the same object. Now let's create three objects. For example, class, then student, def init, self name, self dot name equal to name. S1 equal to student, Priya, then S1 equal to student, S2 equal to student, Aman, So if I print this, so print s1 dot name, then s2 dot name. If I run this, the output will show Aman and Priya. So now understand, when s1 call constructor self become s1, when s2 call constructor self becomes s2, when uh, every object gets its own self. Now let's take one another example of a car, so you will understand easily this concept. So we create a class car, then def init, self comma brand, then self dot brand equal to brand, c1 equal to car, then BMW, c2 equal to car, then Audi, print c1 dot brand, print c2 dot brand. So if I run this, the output will show BMW and Audi. So now notice, both object stores different values because self points to different object. So why self dot name? So why do we write this name equal to name? So suppose we write this, def init self dot name and name equal to name, this. So here Python only copies the local variable. After constructor finish, the value disappear. So nothing is stored inside the object. So this is the correct way to write this, self dot name equal to name. So here the left side belong to the object and right side belong to the parameter. So Python copies parameter into object, means parameter, then name equal to Priya, self dot name, then object memory. So we can use another name instant to self. For example, like we remove this self and abc like this work because self is only a convention, but professional program always use, they never write like abc and x or object, always use this self. So self in normal method is not only used inside constructor. For example, class, then student, then def, init, so self, comma name, self dot name equal to name, def, show self, then print self dot name. If I want to print this as well equal to student, student name Priya, then s2 or s1 dot show. So the output will show Priya. Both methods receive self dot. So imagine you own three cars like BMW, Audi, and Fortuner. Now, when you say my car, so which car? Python asks the same question, which object? So the answer is self dot. So now understand types of constructor. So Python mainly has two types of constructor. First one is default constructor and the second one is parameterized constructor. So let's review both. Default constructor is a constructor that does not require any additional argument from the user. For example, class and student def equal def init, then self print default constructor. Then s1 equal to student, so if I run this, the output will show default constructor. So notice we create the object without passing any extra values. Now parameterized constructor, so a constructor that accept value while creating the object. For example, if I write class student, then def init self dot self, then name, self dot name equal to name, then s1 equal to student, Priya, then print s1 dot name. So if I run this, the output will show this name. So the constructor received this name while creating the object. Imagine you buy a notebook. Notebook number 1 already has date, page number, school name, so everything is already printed. This is like a default constructor. Now imagine another notebook, it's ask you to write name, class, and roll number. So you provide these values, so this is like a parameterized constructor. Now let's see the mistake beginners make. Forgetting, first error is forgetting parenthesis, and the second one is wrong constructor name, like def, then not write this underscore. Third one is missing this self, and fourth one is wrong number of argument. Suppose constructor need two values, for example name, then age. So self dot age equal to age. Now write student 1. So this, now if I print this, so they give me the type error because age is missing. And fifth one is extra argument, like student, if I write 18, so they also give me an error because constructor accepted fewer argument.